Alright, hi. Today we'll be talking about the algebraic side of vectors. And basically we're going to go over order, pair representation, magnitude, the vector operations, and we'll get some examples, and we'll also do a real-world example. Okay, so ordered pair representation. Let's say that Q is x sub 1, y sub 1, and R is x sub 2 and y sub 2. Now what you're going to do is you're always going to follow this rule. Always subtract the first from the second. So that means you're always going to have this little bar right here. This is going to give you the connotation that we're dealing with a vector ordered pair. This is the less than, that's the greater than sign. Okay, x sub 2 minus x sub 1 and y sub 2 minus y sub 1. Okay, so for example, vector st here would be 14 minus 3 and negative 1 minus negative 2. Okay, and that would obviously be 11 comma 1. Okay, so that would be the vector representation of st. Okay, now AB, the vector representation of that is going to be, and I'll just do it straight up in the head. Let's go negative 6. And now if I reverse this, obviously I would be changing the order of the pairs. So I would just be reversing everything. And then that's going to be 4 minus 0, which is just 4. Okay, so if I did BA, obviously it would be a different vector because I'm having a different starting point and a different ending point. Okay, now magnitude is going to be, seriously, we just talked about this in the geometric side, it's going to be the distance formula. Okay, because magnitude is the length in the geometric vectors, so algebraically it's just going to be the distance formula. Okay, now this one, the order doesn't matter. Now when you're doing ordered pair representation, order does matter that you subtract the first from the second. For this one you could have x sub 1 minus x sub 2 or vice versa and just have everything just set up like this. So the absolute value once again is represented by the absolute value bars, so ST is going to be the square root of I'll just minus, so we'll just do that, so it'd be 11 squared, and since you've already have it, you can already do this one, plus 1 squared, which is going to be the square root of 122. Okay, and so that's going to be the magnitude of that one. So you could use the ordered pair representation to actually get the answer a lot faster. Oh, let's put the b in there. We need that for the actual representation. So the actual representation is going to be the square root of 36 plus 16. Oh, let's get this right here. All right, so you got the 36 plus 16, which is going to be the square root of 52. Square root of 52, which turns into 4 root 13. Nope, sorry, not 4 root 13, 2 root 13. Jeez Louise, I think I forgot to how to simplify my radicals real fast. Now vector operations are pretty simple. Once you get them into component form, you can just add the components together if you're adding two vectors together. Subtraction, same as addition, but with subtraction, does need to be stated like that. And scalar multiplication is distribute the scalar to each component. And the components I'm talking about are these two right here, the two components of the actual vector. Okay. All right, now let's say we had an actual problem where we had to deal with something algebraically. In other words, two forces are acting upon an object, 210 newtons at an 80-degree angle with the ground, and 135 newtons with a 72-degree angle with the ground. Okay, so what you can do is you can actually draw these in their horizontal and vertical components. Okay, so as you can see, as what I've drawn here is I've drawn the 210 with the 80 degrees in between as a triangle, and it's a right triangle nonetheless. All right, so Just remember, always have your right triangle, because right triangle trig is a lot easier. And I've talked about this in the past about your physics teacher just saying, use right triangle trig, you'll never go wrong. Yeah, it's good, but then sometimes when you're doing applications, it's a little easier to use law of sines and law of cosines. Once again, getting ahead of myself, let's just figure this out. Okay, so to find out this side of the triangle, sine of 80 equals y over 210. So basically, y is going to equal to 210 times the sine of 80 degrees. All right, and if you check that out on your calculator, probably should have my calculator ready before this. Okay, let's just make sure we're in degrees. Boom, boom, boom. Degrees. There we go. Okay, so 210 times sine of 80. Okay, and that's going to equal around 206, or approximately, oh man, I can't, whatever, approximately 206.8. Okay, and that's just going to be the vertical component. Okay, now the horizontal component is going to be x equals 210 times cosine of 80 degrees. All right, so if we go back, there we go. And this should be approximately 36.5 newtons. And we're talking about newtons. We're not trying to do anything really fancy with it. So I've actually broken down this one into its horizontal and vertical components. So its horizontal component is going to be 36.5, comma 206.8. Okay. Right, and then I could actually find the sum of these two by finding the components of the other triangle. All right, and as you can see, just finishing up, this is 128.6 newtons. Okay, so I found the horizontal and vertical component for this one. So when I wanted to find out the resultant force of this, I would take and I would add the horizontal components first, and that would be 36.5 plus 41.7, comma 206.8, oops, 0.8, plus 128.6. Okay. All right, and just work with it that way, and you could actually figure out the angle of the force as well. Okay. All right, but that is it for this part right here, finding the actual force being done on an object. Obviously, you guys can add it at home. You guys have calculators, so you should be good. But just breaking it down to its horizontal and vertical components, you could actually work with it this way. Okay. All right. Now that is it for talking about algebraic vectors. I will talk to you guys later. Have a great day. Bye.